Good morning. This is your Stat Sensei, Mr. Spensei, and this is Death Packet on chi-square and regression. We're going to be focusing on regression, and this will be problems 11 through 20. Researchers observed the grouping behavior of deer in different regions. The following scatter plot shows data collected on the size of the group and the percent of the region that was woodland. All right. Um, the relationship between group size and percent of woodland appears to be negative and nonlinear. Which of the following statement explains such a relationship? First off, let's look at this. I'm just going to draw a straight line. If I were drawing a straight line for this and modeling with a straight line, I'll use pencil. I would say something along this. But clearly, there's a bit of a curve to it. All right. So, and at what we see here, as woodland goes up, what happens to group size? It appears that group size goes down because it went from up here to all the way down here at 2. All right, as percent of woodland increases, the number of deer observed in a group decreases at a fairly constant rate. It does decrease, but not at a constant rate. As the percent of woodland increases, the number of deer observed in a group increases. No, it doesn't increase. That's the problem with that. As the percent of woodland increases, the number of deer observed in a group decreases quickly. Ooh, yeah, it definitely decreased quickly at first and then more slowly. All right, for number 11, I happen to like C a lot. All right, moving on to number 12. A set of bivariate data was used to create a least square regression line. Which of the following is minimized by the line? Let's look at this. Least squares. Least means minimum. Minimum square. All right. So the minimum square of the residuals. What we're minimizing is the sum of the residuals because this is the minimum of the squares. So it's not the sum of the residuals, but the sum of the squared residuals. And that's why it's called a least squared line because we minimize or least of the squares. So 12 is B. All right, number 13. The following is a residual plot for a linear regression of y versus x. Okay, so right away, I see I have a pattern. We don't like that. That means a linear model is not appropriate, some other model is. So the first one, a linear model is appropriate. No, we don't want a pattern. It needs to be random. B, a linear model is not appropriate. That is correct. So 13 is B. Number 14. Consider the scatter plot of midterm and final exam scores for a class of 20 students. Which the following is incorrect? Be careful with that. Both correlation and slope are negative. And the answer is, well, if I were to draw a line, I have a negative slope. If I have a negative slope, then I'll have a negative correlation. That's a true statement. That's not what we're looking for. The number of students who scored 100 on the midterm is the same number of students scored 100 on the midterm as did on the final. Well, on the midterm, I look at it and I go, oh, 1, 2. And on the final, I look at it and I go, oh, I also have 2. So that's a true statement. That's not what we're looking for. The same percentage scored below 50 on each exam. All right. So let's look at the midterm. On the midterm exam, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 out of 20 or 50%. All right. If I look at the final exam, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So on the final exam, again, 10 out of 20 or 50%. So that's also a true statement. The next one, most students who scored below 50 on the midterm also scored below 50 on the final. Well, we already know that 10 scored, we counted before and said, hey, 10 scored below 50 on the final, I mean on the midterm. But that same out of that 10, only 3 scored on the final. So that's not most. To be most, we'd have to have 6 or more. So we had 3 out of 10. That's not most. D is our best answer for number 14. Number 15, which of the following statements about residuals is, be careful, incorrect? The mean of the residuals is always 0. True statement. The sum of the residuals is always 0. That's true. The sum of the squares is not, but the sum of the residuals is. The regression line for residual plot is a horizontal line. That's true too. That's why we always put the line here at 0 and we have data points going up above it. So the regression line for residual plot, uh, so that's true. The standard deviation of the residuals gives a measure of how the point in the scatter plot are spread out. That's exactly right. Okay, it tells us how spread out they are. A residual equals the predicted y minus the observed y. This is such a tricky problem. All right, residual equals observed minus expected. All right, or O minus E, observed minus expected. So that's why this is wrong. The residual is the observed minus expected, not the other way around. So 15 is E because that is wrong. That's false. All right. Moving on to number 16. Which of the following scatter plots could have resulted in this residual plot? Okay, first off, we have a pattern, so we know we need to have a pattern. If I have a pattern here, that means I'm going to have a pattern, a nonlinear pattern. If I have a nonlinear here, I'm going to have a nonlinear. Well, this is linear, so it can't be that. All right. Now, please remember, residuals are observed minus expected. Okay? This means my observed started off, my observed had to be less than my expected. And here it ended up with my observed is less than my expected. And up here, my observed is greater than my expected. So what I like to do on a problem like this is I'll draw a line through these things and see which one kind of gives me that same thing. But what I see is, oh, here's my line, and my observed is below my expected. My observed is below my expected. Then I have my observed is below my expected. That's what I have here. And right here, my observed is above my expected, and that's what I have here. So I like A for this one. But if I continue on just to show how this works, here I have my observed above it. Well, my observed was supposed to be below it, so it can't be this one. All right. And over here, I still end up with the same situation I just had, where my observed is above my expected, and I need my observed to be below my expected. So the answer to number 16 is, in fact, A. All right, number 17. A linear regression analysis performed on 2 variables. Which of the following tells you that another model is probably a better fit? Correlation R is low. Well, there may not be a good relationship. That doesn't mean that's the case. We just may not have a relationship between the 2 variables. So that doesn't tell me. The mean of the residuals is 0. It always will be. So the sum of the residuals is 0, so the average will be 0. All right? The p-value is low. No. That tells me it probably is a good choice. The coefficient of determination is high. Yes, that's a good sign, but it's not proof. There still might be a better one, and we'll do an example of that in one of our assignments. The residual plot has a pattern. Remember the appropriateness. All right. The appropriateness is the residual plot not having a pattern. They wanted to know which of you tells you another model is a better fit. If we have a pattern, in the residual plot, another model is a better fit. All right. Consider the 3 points, 4, 33, 5, 27, and 6, 15. Please note these are x values and y values. All right. Given the straight line, we can calculate the sum of the squares of the three vertical distances from these points in the line. What is the smallest value the sum can be? All right, so this requires a couple things. First off, I want you to go to mode, go to stat diagnostics, and turn on your stat diagnostics. Also, I want you to be a stat wizard. Make sure your stat wizard's on. All right. Once you have that, go to stat edit and input your data. All right. So I already have my data points in there, 433, etc. I'm gonna see if I can wrong way. Make that show up a little better. There it goes. All right. So you want that in there. And then you're gonna quit out of that. And I'm gonna go ahead and run a test. I'm gonna go run a linear regression t-test, L1, L2. I really don't care what it is. What's really important is I press the alpha button, alpha trace, enter. All right. I've got all that information. Great. Well, it still hasn't done anything, but this has helped me out with what I need. I'm going to go back to stat edit. All right. Go to the top of L3, and I'm going to press blue button and then stats. And I'm going to scroll down to where residual popped up and press enter. Now I have my residuals. Okay. So those are my residuals. And if you notice, they actually -1 plus 2 plus -1. That sums up to 0. But um, what is the smallest value this sum can be? Um, we want the sum of the squares. All right, so it asks for the sum of the squares. The sum is 0, but the sum of the squares is -1 squared plus 2 squared plus -1 squared. All I did was copy that straight off the calculator. Well, this becomes +1. This becomes a +4. This becomes a +1. Those sum to 6. So my answer choice for 18 is B. All right, which of the following gives a proper ordering? So we have these correlations. Well, first off, this one is about 0. This looks like about, that's not a -1, but it's a negative, I don't know, call it a 0.8 because it's pretty tight. And this one's a little bit looser. Let's call it a positive 0.7. It might be a 6.5, but it's not as strong as this one. This might be a 9. I don't know. It doesn't really matter. I just need to know that this is a stronger relationship than this one. But this is negative and this is positive. So, if that's being the case, this is, which of the following is the proper ordering? Well, this negative is lower than any of this. Negative is lower than 0. So we need to start off with a -0.8. That's my lowest value. All right. Then my next value is 0. And then my next value is +7. So I need to find -8, 0, and +7 because that's the order on the number line. Well, that means this is 2, this is 1, and this is 3. So I need a 2, 1, 3. But the only one that has 2, 1, 3 is this one. But the question is, why do they put this there? Well, what's the absolute value of -0.8? The absolute value of -0.8 is 0.8. And so this would definitely be higher. And that's why 2 showed up twice. So my answer choice to number 19 is C. All right, moving on to number 20. Which of the following statements about a least square regression line is always true? A point with a large residual is an outlier. Yes, basically what that's saying is if this is my prediction line and I have a point that's way up here, it's an outlier. If I have a point way down here, it's an outlier. Those that are close are not outliers. So you need the large residual means it's a long way from the prediction line. So a point with a large residual is an outlier. That's a true statement. A point with a high leverage point has a y value that's not consistent with the other y values. Well, that y value is not consistent. That's an outlier. All right. So that's a definition of an outlier. What this should have said is an X value is a high leverage point. So X value that's not consistent. So if I had data points like this, and then way over here, I had another point, and let's just say this is 0, this is 5 to 10. If everything's in a 5 to 10 and then I have a 0 down here or a 1, that's a high leverage point because it's not consistent. So um, this is false because that should have been an X instead of a Y. It's not a typo, it's a trick. All right, the removal of an influential point could change the value of the correlation. Yes, because these points vary a lot, but all of a sudden they don't vary so much when you have that. So this is also a true statement. So we have a TFT. So our answer is D. That's not a very good circling of D. But our answer choice for oh, I'm sorry. Yeah, but the answer choice for number 20 is D. The removal of an entry point could change the value of the correlation um, coefficient. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.